Welcome to Study Loop.
Problem 8.65. So we have a tennis ball with a given weight. Careful to note this is the weight, not the mass. It has an initial velocity of this right before it gets hit by a tennis racket, which it's in contact for with 3 milliseconds, and it exerts a constant force that's given here. And what we'd like to do is find out what is the impulse that this force produces, and then what is the new velocity of the tennis ball after this force is acted upon it. So, before we get anywhere else, let's just real quick be careful and divide the weight we're given by the acceleration due to gravity, and we find that this has a mass of 0.0571 kilograms. Now for part A, we don't need that, but for part A, we have the impulse for a constant or average force is equal just to that force times the amount of time that's spent. So we take our force here, multiply it by 3 times 10 to the negative third seconds, and we end up with negative 1.14 Newton seconds in the x direction. And 0, it's a parenthesis, 0.330 Newton seconds in the y direction. So now we need to use the fact that the impulse is also equal to the change in momentum. So the final momentum is equal to the initial momentum plus the change. So now we have m times v final, the thing we'd like to know, equals m times v initial, which we're given up here, plus our force times the length of time it acts. So you divide through by m, put in the numbers, and we find that this is 0.04 meters per second. And the x direction plus 1.8 meters per second in the y direction.